Hello everyone, I am Sanjit and I welcome you all to this lecture of School from Home. And today we are going to talk about maths to geometry. Maths is a subject that most of us are afraid of. But if it is taught to us in an interesting way and we receive proper guidance for it, maths could be our best friend. And today, to guide us for this subject, we have with us Mangesh Avate sir. Avate sir has more than 40 years of teaching experience. From 1980 to 1995, he was teaching maths in Gambhir classes. After that, till 2010, he was teaching at Peace Oak School. And for the past 10 years, he has been conducting his own classes, that is Avate's classes at Sinhagad Road. So without wasting further time, let us begin with today's session.
In geometry, first chapter is similarity. In similarity, we have these types of properties and theorems. Let us study the properties. In two triangles, areas of two triangles are proportional to the product of base and height. If base is same, proportional to height. Height is same, proportional to base. Both are same, ratio is 1. All these four formulae which are based on 1.1, all the examples which are based on these properties is given in exercise 1.1, practice 1.1. Basic proportionality theorem. This is a very important theorem we come across in this similarity. If PQ is parallel to BC, then we have AP upon PB is equal to AQ upon QC. Converse of basic proportionality theorem. When ratios are equal, their lines are parallel. That is, if AP upon PB is equal to AQ upon QC, then PQ is parallel to BC. Examples which are based on basic proportionality and converse of basic proportionality are there in our example 1.2. Next property, that is median divides the triangle into two triangles of equal area. Because of AD, complete triangle ABC is divided into two triangles of equal area. That is, area of triangle ABD upon area of triangle ADC is equal to 1. That is complete triangle, and these two triangles are divided into two equal halves. That is, area of triangle ABD is half of area of triangle ABC. Now, test of similarities. We have four tests of similarities, that is AAA test of similarity, AA test of similarity, SSS test of similarity, SAS test of similarity. All the properties, all the examples which are based on this test of similarity, they are in exercise 1.3. Now, important example, that is important theorem which is there in our similarity, that is in similarity we have when triangles are similar, then heights are proportional to corresponding sides. This property is used in this theorem. In similar triangles, areas are proportional to square of the corresponding sides. That is, area of triangle ABC upon area of triangle PQR is equal to BC square upon QR square, is also equal to AB square upon PQ square, is also equal to AC square upon PR square, is also equal to AD square upon PA square. All these examples which are based on these two theorems is in 1.4. These are the important properties, theorems which are based in similarity are in front of you. In the first chapter, similarity, the omitted portion is angle bisector and application of Pythagoras. Now we are going to start with the second chapter, that is Pythagoras theorem. In Pythagoras theorem, these are the basic properties 30, 60, 90. We have already studied in 9th standard all these maximum properties which have come across, and all the basic things are like this. Side opposite to angle 30 degrees half the hypotenuse, side opposite to angle 60 degrees root 3 upon 2 times its hypotenuse. In 45, 45, 90, side opposite to angle 45 is 1 upon root 2 times hypotenuse. Hypotenuse is root 2 times the side. Equilateral triangle all sides are congruent, perimeter is equal to 3 into side, height is equal to root 3 upon 2 into side, area of equilateral triangle is root 3 upon 4 into side square. Now we have already studied the square in 9th standard, still it is important in 10th standard, that is perimeter is 4 into side, area is side square, diagonal is root 2 into side, area is equal to half diagonal square. Now in similarity of right angle triangles, in triangle ABC, if measure of angle B is 90, BD is perpendicular to AC. Because of this perpendicular, original triangle and these two part triangles, they form all are right angle triangles, and we have to prove all these three are similar to each other. This property is called similarity of right angle triangle. Geometric mean in triangle ABC, measure of angle B is 90, BD is perpendicular to AC, so BD square is equal to AD into DC. Pythagoras theorem, in a triangle which is a right angle triangle, measure of angle B is equal to 90 degree, then AC square is equal to AB square plus BC square. Here in this 10th standard, we are going to prove the Pythagoras theorem by using similarity of right angle triangle property. Now converse of Pythagoras, if square of the larger side is equal to sum of the squares of other two sides, then that triangle is a right angle triangle, that is measure of angle B is equal to 90 degree. Now examples which are based on sides of a triangle is called triplets of Pythagoras. These are the triplets of Pythagoras we are going to come across in 10th standard. Not only this, and multiples of these are also there, 3, 4, 5, 5, 12, 13 and so on. Now in this chapter, omitted portion is this application of Pythagoras and Apollonius theorem, that is from page number 40 to 43 is omitted. All these examples you can solve from 2.1 to 2.3 based on these properties which are very important. Now we are going to study very important chapter, that is circle. Circle is having maximum marks in geometry paper. So we are going to study the basic also, which we have already studied in 9th standard, that is perpendicular bisects the chord, bisector is perpendicular to the chord, congruent chords are equidistant from their centers and vice versa. When chords are congruent connected, arcs are congruent and vice versa. When chords are congruent connected, central angles are congruent and vice versa. Now these theorems are very important for writing. Tangent perpendicularity theorem. Converse of tangent perpendicularity theorem, that is a line which is perpendicular to the radius at its outer end is tangent to the circle. We can draw tangent segment theorem. Tangent segments which are drawn from a point outside the circle are congruent, that is PT is congruent to QT. When two circles touch each other externally, then distance between their center is R1 plus R2. Their center and a common point are collinear. Line passing through their center is perpendicular to the common chord. When two circles touch each other internally, then distance between their center is R1 plus R2. Line passing through their center is perpendicular to common tangent T at M. When two circles are intersecting each other in point P and Q, then PQ is called a common chord, and line passing through their center is a perpendicular bisector of the common chord. Now important properties which are compared with circle and angle. Central angle property. When the vertex is on the center of a circle, then angle AOB is called a central angle, and the measure of angle AOB equal to measure of arc AXB. Inscribed angle theorem. Measure of angle ABC is half of measure of arc AXC. Angle inscribed in the same arc are congruent, that is angle APC and angle AQC are inscribed inscribed in the same arc, so these two angles are congruent. Angle inscribed in a semicircle is a right angle. If the angle ABC is inscribed in a semicircle, it intercepts semicircle, and that is 180. So measure of that angle ABC is half of the intercepted arc according to the inscribed angle theorem. Opposite angles of a cyclic quadrilateral are supplementary. When all 4 points A, B, C, D of a quadrilateral lie on a circle, then that quadrilateral is called a cyclic quadrilateral. In a cyclic quadrilateral, opposite angles are supplementary, that is angle A plus angle C is equal to 180, angle B plus angle D is equal to 180. In this chapter, tangent theorem, converse of tangent theorem, tangent segment theorem, inscribed angle theorem, angle inscribed in a semicircle, angle inscribed in a same arc, opposite angles of a cyclic quadrilateral, out of these one theorem is there for writing the proof. Now in this chapter, omitted portion is tangent secant theorem and converse, internal division of chords and external division of chords, that is from page number 75 to 82 and 3.5 exercise. In chapter number 4, which is a geometric construction chapter, these are the two basic things. We have to draw perpendicular to the given segment. Put your rounder on A and draw two arcs. Same thing from B to the intersecting previous arc, and line passing through them is the perpendicular bisector of the given segment. Similarly here, and these two things are used in this construction, which is for us tangent to the circle from a point on it. We have to take a point P and put your rounder on P and draw two arcs, and taking your rounder on these two arcs, draw two arcs which are intersecting on the opposite side of the line, and draw a line passing through them is a tangent to the circle. This is another construction. Draw a tangent to the circle from a point on it without using center of a circle. Here we are using center of a circle. In this case we are not using the center of a circle. If a point A is a point of contact, we have to draw any triangle. In that case all the vertices are on the circle. Draw congruent angles at point from a B and at point A, and draw a line passing through this. Because these two angles are congruent, then this line becomes a tangent to the circle. Draw a tangent to the circle from a point P which is outside it. In this case, if the distance OP is given to us, radius is given to us, then we have to draw perpendicular bisector of OP, that is M, which is a center of the next circle. Draw a circle which must pass through point O and B, and this circle intersect the previous circle at point A and B, that is point of contact. And you have to draw the lines passing through point A and P, passing through point B and P. These are the two tangents to the circle from a point P which is outside it. In given exercise 4.1, there are two variety, that is 4.1, example number 1, 2 and 3, they are of the same type, that is both the triangles have different vertices. So we have to draw both the triangles by using 8 and 9 standard method, that is by SA, S-test, SS, S-test and so on. In example number 4 and 5 from 4.1, here how to recognize this, that the vertex in both the triangle A is same. In that case you have to draw one triangle, and you are given that ratio, that is AM upon AH is equal to 5 upon 3. Draw a line and take 5 equal parts, join fifth part to AM because AM is equal to 5, and draw third line here. From this third line, this is a point H, we have to draw parallel line MT to this HE by making congruent angles here, so that you will get AMT is similar to AHE triangle. That's all. in coordinate geometry we have only four formulae. First is distance formula. If AB is the distance, A x1 y1 and B y1 x2 y2 are the points on the line, then distance AB is equal to under root x2 minus x1 bracket square plus y2 minus y1 bracket square. We have to substitute the values in the formula in the bracket only because negative sign is there before x1, so we have to take care of that. In our exercise 5.1 we have there check whether the A, B, C are collinear or not. In that case we have to use this. When distance AB plus distance BC is equal to distance AC, then A, B, C are collinear, that is A dash B dash C is true, or and vice versa. In section formula, if P divides AB internally in the ratio m is to n, then we have x is equal to mx2 plus nx1 upon m plus n, and y is equal to mx2 plus my2 plus ny1 upon m plus n. Here m and n are the ratios, they are always positive. So while substituting the values of the coordinates of the point x1 y1 and x2 y2, we have to make a bracket of x2 x1 y2 y1 only because m and n are always positive. Third formula, that is midpoint formula, which is very simple. P divides AB in midpoint. That means if P is a midpoint of AB, then x is equal to x1 plus x2 upon 2, y is equal to y1 plus y2 upon 2. Fourth formula is the centroid formula. When centroid is used in a triangle ABC, if AD is a median, then G point, which is called a centroid, which divides AD in the ratio 2 is to 1, and G is the coordinates of the point xy, then we have our formula, that is centroid formula, finding out the coordinates of the point G, that is x is equal to x1 plus x2 plus x3 upon 3, y is equal to y1 plus y2 plus y3 upon 3. Complete chapter is based on this four formulae, and last 5.3, that is omitted portion, is that slope of the lines and parallel lines we have omitted in this time, that is from page number 116 to 121, that is practice set 5.3 is not there. Here this is the chapter which is very simple, only we have to substitute the values of the formula and find out the answer to pass it, to get maximum marks. This chapter is very simple. Sixth chapter is the trigonometric chapter, that we have already studied all these formulae in 9th standard. All these formulae are based on trigonometric ratios, that is there are 5 groups here. Sin theta is equal to cos 90 minus theta, cos theta is equal to sin 90 minus theta, and so on. Reciprocals, 1 upon sin is equal to cosec, 1 upon cos is equal to sec, 1 upon tan is equal to cot. These 3 formulas are very important while finding out the expression, that is show that, prove that in our exercise. That is, here there are some examples which are based on this. We are given that the value of sin theta 5 upon 13, and you are supposed to find out the third side or to find out the other ratio cos theta. Since we are using trigonometric ratio, we can use the trigonometric ratio for a right angle triangle only. That means indirectly sin ratio is given, means out of the 3 sides, 2 sides are given to us. To find out the third side, either we can use Pythagoras theorem or we can use this sin square theta plus cos square theta is equal to 1 formula to find out the other ratio. If we know sin and cos, we can find out tan. If you know tan, we can find out cot, and if you know sin and cos, we can find out cosec and sec also. That means after finding out the third side by using Pythagoras or by these 3 formulae which are trigonometric formulae, we can find out the third side or other trigonometric ratio. There are another examples which are based on this, that is solve or to prove that, show that, solve LHS. In that case we have to find out LHS first and RHS secondly. That means LHS and RHS are separated. Solving separately is very important. If you solve LHS and RHS by using is equal to sign, you will not get any mark in the exam. The third, that is a 6.2 exercise which is based on word problem. There are some important word problems in our example, in our chapter trigonometric ratio. That case we have to use these two things. That means this is our horizontal level. Angle of elevation means we have to increase our eye level from the horizontal to the given ratio or temple or top of the building. That is called angle of elevation. And angle of depression means we have to see downward from the horizontal level. That is called angle of depression. While solving this, we have to read the given example and convert the given information into right angle triangle and use the trigonometric ratio, so that you will get the answer and substitute the values √3 and other things in the given example. Here some trigonometric ratios, sine the 0, 30, 45, 60 angles are given. We have already studied in 9th standard. We have to substitute the values and find out the answer. This chapter is very simple except the word problems. You have to study the word problems carefully and concentrate on these formulae, so that you will get full marks in this trigonometry. In geometry, last chapter is mensuration. This complete chapter depends upon only formulae. We have already come across this formulae, but the formulae are very important as far as this chapter is concerned. Only you have to substitute the values in the formula and you will get marks. First formula, that is cuboid. Volume of cuboid is length into breadth into height. Area of vertical faces, that is 2 into bracket L plus B into H. Total surface area, that is 2 into bracket LB plus BH plus LH. If length, breadth and height all are same, it becomes a cube. Then volume of cube is equal to L cube. Area of vertical faces 4L square. Total surface area 6L square, and diagonal is √3 into L. When we can use volume, when we can use area of vertical faces, and when we can use total surface area. If you want to find out how much water contain in it, how much something contain in it, we have to use volume formula. To find out the area of vertical faces, if I want to find out the painting of the walls, wall painted, that means in that case you have to use a formula area of vertical faces. And if I want to prepare a box like this, cuboid or cube, then I have to use the formula total surface area 6L square. Same case with the cylinder. Volume of cylinder is pi r square h. Curved surface area is 2 pi r h. Total surface area, that is 2 pi r into bracket r plus h. How much water contain in it in a cylinder? We have to use volume pi r square h. To find out the plastic required for a pipe, that is 2 pi r h. And to find out the total tin sheet required to prepare a cylindrical box, we have to use the formula area of cylinder, the total surface area of cylinder, that is 2 pi r into bracket r plus h. Volume of sphere is 4/3 pi r cube. Curved surface area, that is 4 pi r square. If this sphere is cut, then it becomes a hemisphere, and volume of that is half of this, that is 2/3 pi r cube. Curved surface area, that is curved portion, is 2 pi r square. Total surface area is this curved portion plus cut portion becomes 3 pi r square. Very important formula in this chapter is cone. L is the slant height, H is the real height, and R is the radius. Then volume is 1/3 pi r square H. Curved surface area is pi r L. Total surface area is pi r into bracket R plus L. If this cone is cut in between from the top some distance, then it becomes a frustum. Then volume length of slant height L is called under root h square plus r1 minus r2 the whole bracket square. Curved surface area, that is pi into bracket r1 plus r2 into L. To find out the frustum's formulae, we have to substitute in this cone formulae r1 and r2 in place of r. If you substitute r1 and r2, r1 plus r2, you will get curved surface area of this. If you substitute r1 plus r2 in total surface area, you will get this formula. To remember this is very simple. And in volume of frustum, there is r1 into r2, this portion extra is there instead of 1/3 pi r square h. If you substitute r1 and r2, it becomes 1/3 pi r1 square plus r2 square plus r1 into r2 into h. Now circle. We have already studied this basic formula. We forget this, so we have to remember this. R is the radius, D is the diameter, C is the circumference. C is equal to 2 pi r, that is pi d, area pi r square. Semicircle, that is half circle, circumference is 2 pi, perimeter is pi r plus 2r, area is half pi r square. This is a new concept, that is sector. If the circle is cut in between at the center like this, this portion is called a sector. R is the radius. If theta is the central angle, then area of sector is theta upon 360 into pi r square. Length of sector is equal to theta upon 360 into 2 pi r. And we have one more formula, area of sector is LR upon 2. If you substitute the values in this formula, you will get full mark. The omitted portion in this chapter is area of segment from page number 156 to 160 and problem set 7.4. Now we have studied all the 7 chapters of the geometry, and we come across maximum formulae and maximum theorems. If you study all the formulae in the geometry which are given in our series, you will get maximum marks, and theorems which are given in our textbook. To learn this, we have to study regularly and for the exam. All the best for your SSC board examination. Thank you.
Thank you so much for watching this video. If you like this video, do let us know in the comment section. If you think this video was useful, do share it with all your friends from the 10th grade. Do subscribe to YouTube channel of Lifelines. Do watch other videos in this series and also watch our other interviews. I am sure you'll love them. If you want to contact Avate sir, you can find his contact details in the description below. You can also find our email ID and Instagram ID in the description. So if you want to contact us, feel free to do so. Thank you so much.